Let's start at the very beginning. A very good place to start. When you sing, you begin with do, re, mi. And when you build statistical models, you begin with linear regression. Okay, so I don't think that song is going to catch on. But the point is this. We're interested in building models to explore and predict the relationship between variables. And the simplest type of relationship we could think to build is a straight line. Also, as you'll see, many relationships in the world tend to be linear, or they can be transformed to linear. So actually, this is a very powerful place to start. So let's go. Let's look at our first linear relationship. Here's a data set showing the relationship between the average number of rooms in a house and the median house price. It's from 506 census tracts in Boston from 1970. You can find the data set in the link under this video. It's also available as Boston Housing 2 in the MLBench library in R. Create yourself a scatterplot using ggplot. You can look back at section 2 from our computational thinking and big data course to do this. What do you notice? There's a strong linear relationship between average house price and the number of rooms. Does that make sense? It should. Here's another plot, which we'll delve into more later. It's between the price of a diamond and the number of carats, and it uses a fancy hexbin plot to show the relationship. You might need to install the hexbin package to make this one. Now that doesn't look particularly linear to me, but with a quick transformation we can make it be so, like this. So linear relationships can sometimes be there in disguise. This is a theme we'll come back to throughout the course. We'll talk about how to fit a linear model to this dataset soon, but first, let's lay down some notation in the next unit.